Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to work with positive, negative, and fractional exponents on integers and variables, and how to perform basic exponential operations and recognize like terms. How are we learning it? Through the negative and fractional exponents part 1 notes and the negative and fractional exponents part 1 assignment. When can we use this? To calculate the amount of money owed on a loan including interest. How do we know we learned it? By getting a score of 4 on the negative and fractional exponents part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the negative and fractional exponents part 1 notes, and then I'll give you time to complete the negative and fractional exponents part 1 assignment. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the exponential function study guide and any incomplete assignments that you may have. Let's take a look now at the negative and fractional exponents part 1 notes. The notes begin with the learning goals and success criteria. Now, what is an exponent? An exponent is a number that tells you how many times to multiply the base number by itself. So for instance, we have 2 to the third power. 2 is what we call our base number, and it tells us that we're going to multiply 2 times itself 3 times. So that's really 2 times 2 times 2, which is 8. Now let's talk about positive exponents. So positive exponents mean that the number above here, the number of times that we're going to multiply it times itself, is a positive number. So we have 5 squared. Well, that means that we're multiplying 5 times 5, which in this case is 25. Then we have 5 to the third power, which is 5 times 5 times 5, which is 125. And then 5 to the fourth power is 5 times 5 times 5 times 5, which is 625. So we can do this with any exponent. We can take any base number and raise it to an exponent and multiply it by itself a certain number of times and solve. Now what about 0 and 1 exponents? So 5 to the first power. Well, 5 to the first power is just 1 5, right, times itself, so 5, that's it. So that's just 5. Now 5 to the 0 power. So there's 0 5s, and that's equal to 1. Now, please make sure that you understand this. Any number raised to the 0 power will always be 1. So not 0, but 1. So 5 to the 0 power is 1. 2,000 to the 0 power is 1. 200 million to the 0 power is 1. So any number raised to the 0 power is just 1. Now let's take a look at negative exponents. So a negative exponent looks like this, where it's 5 to the negative second power. Now here's the rule with negative exponents. When we're working with a negative exponent, we're going to rewrite as the reciprocal, meaning instead of this being 5 to the negative second, we're going to write it as 1 over 5. And then we're going to change the power to a positive. So 5 to the negative second becomes 1 over 5 squared. So I made the power positive and put it under 1. Now I just do it like normal. So 5 squared is 25, so this is 1 over 25. Now 3 to the negative third power. So again, that becomes 1 over 3 to the positive third power. 3 to the positive third power is 27, so it's 1 over 27. Now we have x to the negative sixth power. So we're going to flip that and it becomes 1 over x to the positive sixth power. Now let's take a look at fractional exponents. For instance, we have 25 to the 1/2 power. So what we're going to do is we're going to take the base number, 25, and we're going to raise it to the power of the numerator. So it would be 25 to the first power. And then the denominator is going to make up the root we're going to take. So in this case, it will be the second root or square root. So the way that looks is we're going to have 25 to the first power, which is just 25. And then we're going to take the square root of that, just like this. So we need to know what number multiplied by itself gets 25. Well, we know that 5 times 5 is 25, so the square root of 25 is 5. Let's look at another example. We have 3 to the 1/3 power. So again, we're going to take 3 to the first, and we're going to find the cube root of it. Well, what times itself 3 times equals 3? Well, we should recognize that it doesn't come out evenly. There's no whole number that does that. So we're just going to leave it as cube root of 3. Now we have x to the 2/3 power. So what we're going to do is we're going to take x and raise it to this power. So it should be x squared. And then we're going to take the cube root of that. So the third root of x squared. And we should notice that there's no number that we can multiply by itself 3 times to get x squared. So we just leave it as cube root of x squared. Now what if we have a negative and a fractional exponent? Well, we do the same thing we did on the previous two. We're going to go ahead and flip it and make it positive. So we're going to, x to the negative 1/2 becomes 1 over x to the 1/2 power. Just like that. Now we know that we're going to take the 1/2 power, and that becomes x to the first, and then we're going to take the square root of that. So that becomes 1 over the square root of x to the first, which is just x. Now combining like terms, if we look at this, we're going to combine like terms, and the rule is in order to combine like terms, they have to have the same exponents and same variables. And if they do, we're going to add the coefficients. So for instance, we have 2x and x. Well, they're both x's, so they have the same variables, and they have the same power, same exponent. Really, it's imaginary exponent of 1. So we can just add these. 2x plus x is 3x. We have 3x squared plus 4x squared. Again, same variable, they're both x's. And the powers match, so we just add the coefficients. So that's 3 plus 4, which is 7x squared. We can do it with subtraction as well. So we have 6x cubed minus x cubed. Well, again, same variable, same power. So now we can go ahead and subtract. So 6 minus 1 is 5x cubed. Now we have 7x to the 4th minus x cubed. Well, again, same variable, but this time they do not have the same power, so we cannot combine them. It just stays 7x to the 4th minus x cubed. Now when we multiply or divide exponents, so the rule is this: when we multiply or divide exponential terms, even if they do not have the same exponents but have the same variable, we can still do it. The rule is we multiply or divide the coefficients and add or subtract the exponents. So if we're multiplying, we're going to add the exponents. So this is 2 times 1, so that's my coefficient. And I have an x to the first and an x to the first, so I'm going to add those exponents. So I get 1 plus 1 for my exponents. So 2 times 1 is 2. And 1 plus 1 is 2, so it should be 2x squared. So look at another example of multiplication. So we have 3x cubed times 4x squared. Now with this one, again, we're going to multiply the coefficients, so 3 times 4, and we're going to add the exponents, so 3 plus 2. We end up with 3 times 4, which is 12x, and 3 plus 2 is 5, so we get 12x to the 5th power. Now division is just the opposite. So we're going to divide the coefficients and subtract the exponents. So we get 6x to the 7th divided by 2x to the 3rd. So we're going to divide the coefficients, so 6 divided by 2, and then subtract the exponents. So it's x to the 7 minus 3rd power. So 6 divided by 2 is 3, and 7 minus 3 is 4. So we get 3x to the 4th. Now here we have 7x to the 4th divided by x cubed. So again, we're going to divide 7 divided by 1. And x to the 4th minus 3, which is 7 divided by 1 is 7. And x to the 4 minus 3 is first power. And whenever it's the first power, we don't need to put it there, so it's just 7x. Now what if we have the coefficient and variable inside of parentheses and the power outside? Well, when we do that, we're going to raise the power by multiplying the exponents. So in this case, we have 2x, and this is x to the first, And we're going to multiply the powers for each of these. So this is really 2 to the first power times 2, and x to the first power times 2. So that's really 2 squared times x squared. Well, 2 squared is 4, and x squared is just x squared, so it's 4x squared. Now let's look at this one. Again, same thing. This is 3 to the first and x squared. So we're going to multiply each of those by the power out here, which is 3. So we got 3 to the first times 3 and x to the second times 3. Well, we know that 3 to the first times 3 is 3 cubed, and 2 times 3 is 6. So we got 3 cubed times x to the sixth, and 3 cubed is 27. So it's 27x to the sixth. Now for this one we have x squared times y cubed, and we want the whole thing squared. So again, we're going to multiply it. So x squared times 2 and y to the third times 2. And we get x to the fourth, y to the sixth, because we multiply 2 times 2 is 4 and 3 times 2 is 6. Now we have x y squared z cubed to the sixth. So we're just going to multiply each of the exponents by 6. So we get x to the first times 6, and y to the second times 6, and z to the third times 6. And we're just going to multiply these out. So 1 times 6 is 6, 2 times 6 is 12, and 3 times 6 is 18. So we should get x to the 6th, y to the 12th, z to the 18th. Now let's look at the negative and fractional exponents part 1 assignment. Our assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. We'll look at our questions for today. So the first one says, what is 3 to the third power? Well, 3 to the third power is 3 times 3 times 3, which is 3 times 3 is 9, times 3 is 27. So that would be our answer. We'll continue to scroll down. I want to take a look at this one. It says 2 to the negative fourth power. Well, remember, whenever it's negative, we're going to flip it and make it 1 over 2 to the positive fourth power. So that's 1 over 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 again is 16. So it should be 1 over 16. Now let's find one with a fractional exponent. So here, 169 to the 1/2 power. Well, remember, 1/2 power means that we're going to take the square root of it, because we're taking the second root of 169. Well, the second root of 169 is the square root, so the square root of 169 is 13. So this will be our answer. So you'll continue to answer all these questions all the way until you get to the end. Once you get to the end, you'll click Next. This will take you to your Before You Go. Fill out your Before You Go, and then submit your work on Google Classroom.